Hello, everyone. Welcome to the conversation with different faculty members of School of Climate Change and Sustainability from Azim Premji University. I am Neeti. I am a faculty member in the same school. So today we have, in the first of this series, we have our faculty member Dhirendra Kumar. He is going to talk about how climate modeling affects the policy. He is a climate modeler and a climate scientist. He works on different risk modeling and he has a number of years of experience in the field of climate modeling. Over to you, Dhirendra.
Uh, Thanks, Neeti. Hi, everyone. Uh, Thank you for joining us today. We are going to talk about today how the climate data and the climate science in general informs and influences global policies at different levels. Lately, you would have heard about a lot of news about climate change in media, specifically talking about the news of weather and climate disasters, which have been repeatedly occurring over the Indian region and causing a lot of damage to the infrastructure, but at the same time also taking away a lot of human lives. The impact of climate change is not a distant threat, but it's a reality of our current times. And thus, it becomes really important to discuss about these, understand them better, and also join hands to coordinate efforts in order to address these challenges for making a resilient society. So, in the couple of slides which we are going to discuss today, I'll be covering a little about um, the basics of climate change and also a little about how the Earth system works, where the climate and weather events happen, and what is the science behind climate change, how the climate disasters have been occurring, what sort of changes have been introduced to the atmosphere on account of human activities, and how scientists tend to study them. So moving on, to set the context, this is something which I was talking about. This is the state of affairs today. This is where we are. You would have heard of a hot debate on the human society breaching the threshold of 1.5 degrees Celsius global warming, especially in the last year. So, what has happened compared to the pre industrial levels, where there was not much intervention by human society? The globe has warmed by 1.5 degrees Celsius in general on average. Now, what this means? This means cascading impacts across different societies, different sectors, and also different components of the Earth system. Some of which we have been facing lately, something like extreme weather and climate events. I have put together some of the examples here. Something like Himachal Pradesh suffers losses of approximately 1,500 crores during ongoing monsoon season because of a lot of weather and climate disasters over there, a lot of heavy rainfall and extreme rainfall events, floods, etc. Apart from that, you would also have heard about the extreme heat events across different parts of India. And that does not only result into the health impacts, but also kind of have cascading impacts in terms of loss of labor productivity and also some of the infrastructure, supply chain, etc. So the impact doesn't stay in a particular sector, it keeps moving. Okay. Um, I will give you another example of last week's deadly cyclone, which is called Melissa, something like the one you see here, the news report about Storm Melissa, which is named as Pure Fury. So it has sparked a debate on whether we have breached some sort of thresholds of typology of the events which we have been having, and whether we are now going to experience a different set of events which we have never seen before. And these kind of events are unprecedented. These have not been observed. These are so intense. not only in terms of its magnitude, but also in terms of its characteristics. And thus, we need coordinated science to understand it better, not only from a physical science perspective or climate science perspective, but also how it impacts the society in general. What sort of preparation we have to make in order to make our societies resilient. All right. Apart from that, you would have also heard of flash floods. I'll give you another example of heavy Bengaluru rains a couple of months ago, which created a lot of havoc, and many of the areas were submerged. The schools were closed, many of the offices, they issued the advisory, and then it results into ultimately the financial loss, but also disruption of multiple set of affairs which we have in day to day. Talking about the impacts of climate change specifically for India, we are one of the countries which is very highly ranked for the impacts of climate change. So we are much more vulnerable. So if you see on the right side of the table, there is this report which suggests that India ranks sixth globally in terms of the exposure and vulnerability to the impacts of climate change. Another instance which I can give, when I was growing up, I did not used to hear about frequent tropical cyclones occurring in Arabian Sea, right? And then we learned as part of our geography lessons that Bay of Bengal is the place where most of the cyclogenesis happens, and then it travels towards the inland parts of India. But lately, what has been observed, because of the changes in the sea surface temperature, changes in the ocean conditions, we have observed a lot of cyclogenesis in the Arabian Sea, which is unprecedented and unexpected. Moving on, I will give you a little overview about the Earth system, right? We see our Earth, which is a very unique planet, and it consists of four different components. The one is atmosphere, where most of the weather and climate event happens. Another one is hydrosphere, which is occupied by the majority of oceans and water bodies. So we know that Earth is occupied 71% by the ocean, and the rest of it is land. The third one is lithosphere, where most of the land-dwelling animals, including us, and also a lot of biodiversity and plant lives. Then there is this biosphere, which is kind of which consists of these living components, right? And you might wonder that, okay, these are four components and these remain in isolation, but perhaps that is not true. They keep interacting with each other all the time, and they have the feedback effects, right? So for example, atmosphere and ocean, they tend to interact at different levels. And when I say different levels, so something in the oceans happening today will perhaps affect the atmosphere on an account of a couple of days later on, okay? Or perhaps a couple of months as well. You may have heard of a coupled ocean atmosphere phenomena, something like El Nino in the news reports, or La Nina, right? Which affects our weather and climate. The similar thing happens with the lithosphere. So what happens is the soil moisture and how the water is stored in that, how the vegetation is over there. These all things, they kind of contribute to the atmosphere. And then atmosphere in turn also affects the processes over lithosphere. And thus same in the biosphere as well, where there are a lot of gaseous interactions, gaseous exchanges which are happening. And then they tend to give feedback to each other, interact with each other, and then these result into the kind of environment we live into. Okay. Now you may think that, okay, if this is it that simple? Perhaps not. So what happens is, whatever is happening over the earth, whatever processes are happening, those are driven by the energy. And energy is coming from the sun. So we depend, the earth for its function depends a lot on the solar insolation received. And also different parts of earth receive the solar insolation differently, in different amounts, okay? You may also have heard of the greenhouse effect. So naturally, greenhouse effect occurs because of the presence of certain set of gases, which are known as greenhouse gases. And what they do is they kind of act as a protective layer for the Earth to maintain its thermal balance, to maintain the livable temperature on the Earth. Okay. Uh, but lately, what has happened that there has been changes in the amount and concentration of greenhouse gases because of human activities. So on this cartoon over here on this slide, we see that this is our Earth, okay, and then there are different components. Some are part of the atmosphere, something like aerosols. Some emissions are coming in form of greenhouse gases, and then they tend to affect our physical climate, the kind of temperature we have, the kind of other weather parameters we experience on our day-to-day basis. And then there are industries, then there are ecosystem. So everything keeps interacting. You see the direction of arrows, which represents how the interaction takes place. So this is a very complex set of interactions which lead to the functioning of the Earth naturally. But then what has been happening is that balance, that delicate balance has been disturbed, right? Now, we have been talking about weather and climate. So let me give you a brief overview about what weather is and what climate is so that we are clear and we are on the same page. So weather is the instantaneous state of the atmosphere, right? So whatever you see at a particular instance of time. And then there are certain parameters and metrics on which we tend to quantify weather, right? And it is very short term. So something like day-to-day conditions, so temperature today, temperature tomorrow, wind speed, the total amount of sun, how much clouds are there in the sky. And based on these conditions, we tend to decide on what sort of activities we have to do and how we have to adapt according to that. So consider if it is going to rain, if you see a report, a weather report where it says that it is going to rain today, and if you happen to trust it, if you happen to adapt according to it, you will definitely carry an umbrella, right? So weather is important in that way, right? For shorter scale plannings. But climate is something which is an aggregate of weather for a longer period of time, something like 30 years, 40 years. Now, why would you need climate? The reason being, you want to know that on an average, how it behaves, how a particular place's weather behaves, right? And then what you do, you tend to kind of take the long-term mean, and then these average conditions represent your climate. And this decides your wardrobe, for example, right? So what you can say is, okay, today's weather is going to be 40 degrees Celsius. That's fine. We are talking about today or tomorrow or the day after, something like that at a shorter period. But for the climate, what we will tell is, oh, perhaps Uttarakhand has a cool climate, right? But we are talking about climate, not the weather. Weather is for a particular day or week or month or something like that. But climate, because we know from our experience, whatever data has been collected, we know that, okay, in this season, in this month, this is the average weather which we can expect. So what they say is, weather is what you get. Yes, weather is what you get and climate is what you expect. Okay. Right. I was talking about some of the parameters using which we measure weather, something like temperature, air pressure, humidity, wind, and cloudiness, right? And you see this thin blanket of air, which is called atmosphere around the Earth. We tend to measure these parameters along with others within this blanket itself, right? And these are very basic parameters, okay? So we talked about climate and weather. Now let's talk about what is climate science then. So climate science is the study of Earth's atmosphere, oceans, and biosphere interactions. So remember, when I was discussing the Earth system, I said that all these spheres, they tend to interact with each other across different scales of time and space, okay? And then the climate science also focuses on long-term weather patterns for a particular region, and also its trends, how it is going to change, how it has been, and what can we expect for the future. Okay. The way we do it, we use a lot of data from satellites, weather stations, and climate models. So in context of India, just try to visualize that if you come across an IMD station, India Meteorological Department measuring station, okay, or some sort of automatic weather station which people may have at their place or any firm may have at their place for recording these weather parameters, okay. But at the same time, we use climate models as well. So climate models are a representation of the Earth processes, Earth system processes, where we tend to represent the physical, chemical, and biological processes in terms of mathematical equations. Okay, and those mathematical equations are solved by sophisticated computers because, as I said, all these spheres interact with each other, so we cannot solve it for one place, right? As I said that there are oceanic processes which happens in remote oceans which affect weather back in India or on the land mass. Okay, so we tend to solve the whole globe using these sophisticated climate models, and then tend to understand how it behaves, not how it has behaved in the past, how it behaves presently, and how it is going to be in the future given the human interventions. Right. A little bit about science of climate change. I already said that the whole process on the Earth, it is being driven by the solar energy. So here is this cartoon which shows that we receive a lot of solar insolation, solar radiation on Earth. Some of it is reflected in the space. Some of it is lost in the outer space. And many of it is received at the Earth's surface, which is absorbed by the Earth's surface. So imagine that one place will have concrete, one place will have vegetation, plants, etc. There will be a particular kind of soil, there will be a water body and different kinds of surfaces, and they behave differently to the radiation, right? Some of them reflect it, some of them absorb it, and then they slowly release. So what we say is we receive the solar energy in form of short waves, and then it is absorbed at the Earth's surface, right? And then it is converted into long waves and released slowly. And these long waves are again trapped in the atmosphere of Earth by the gases, right? And they produce a warming effect. If it was a natural process, everything was in equilibrium, right? And very much required for maintaining the Earth balance. But since it has been accelerated, this balance has been disturbed, right? What happens is we have this in the natural setting, very much essential for maintaining the Earth's radiation balance, right? But then this process has been accelerated. This process has been hampered, okay? And because of that, we see that a lot of warming happens in the atmosphere, right? And because of that warming, the delicate balance in other spheres of Earth is also disturbed, okay? Something like changes in the ocean temperature, because remember, ocean and atmosphere interact as well, okay? Then there is there are these greenhouse gases, something like carbon dioxide, methane, nitrous oxide, etc. So these carbon dioxides, they also interact with the ocean, not only to raise its temperature, but also to increase its acidity as well by the formation of carbonic acid, right? And that is also one of the impacts of climate change, ocean acidification. Right. So we talked about global warming, right? Because the temperature change has been happening. And what happens, like, is every place on Earth is warming equally? Perhaps not, okay? So what happens, global warming has disproportionate effects or impacts which lead to different types of weather systems across different parts of the world, or different types of impacts as well. Something like rising sea level, because once What happens is, if the global temperature increases, the water which is frozen as part of the ice caps, polar ice caps, that melts, and then it contributes to the rise of sea level. And at the same time, if your glaciers are melting, that finds its way through rivers to the sea, and at the same time you are losing quite a lot of fresh water. So imagine that the hydrological cycle, which is essentially the circulation of water over Earth through different processes, that is getting hampered because of global warming, right? And then because of that, there are changing weather patterns, something like extreme monsoon rainfall, or uh, a, a lot of rainfall where it is not supposed to rain, and when it is not supposed to rain, and no rainfall in the regions where it is expected to rain. So that leads to a drought condition, right? And that relates to the fact that we have seen a lot of increasing extreme weather and climate events in the recent past. And that not only includes the rainfall, temperature, drought, but that also includes cyclones, which has never happened. That also includes wildfires, that also includes landslides, and much more. And this is not only because of climate change, this also amplifies because many a times these interact with other kind of changes which we are doing to our earth system. Okay, what else happens because of that? The social inequalities widen. So we all know that the kind of societies we live in, there is already a lot of disparity, and the wealth aggregation or wealth accumulation is different in different societies, and there is always a divide between the rich and the poor. So imagine that the climate change intensifies certain sort of impacts, and what it will do, the divide between the rich and the poor will increase. Why? Rich may have the mechanisms and resources to cope up with the impacts of climate change, while poor may not have. But again, this disproportionate impact doesn't discriminate. It impacts everyone equally, right? But the poor may not be able to cope up with the impacts easily. Okay. Um, so so far we have been talking about only the physical impacts, right? You may wonder, oh, okay, what's the big deal? Rainfall happens. So if it rained, it rained. If it doesn't matter if it rained a little or if it rained a little less or more. Okay. Uh, if there is temperature, okay, how am I getting affected? The way we are getting affected is if it is very much extreme rainfall or extreme heat and other sort of events, it directly leads to a loss of human life. But at the same time, many of them have health effects as well. So, for example, extreme heat, it may result into different sort of impacts in different age groups. So you may have heard of heat stroke, dehydration, and many of the people, they are not able to cope up with the heat extremes, and that's how it results into different health conditions. Okay, and then this is not only for humans. The impacts are not only for humans. This applies to different parts of the ecosystems, different organisms, affects the biodiversity, affects the cropping patterns, and much more. Okay. So we are talking about human causes of climate change. We already discussed the greenhouse gas emissions, which is coming from the accelerated use of fossil fuels, especially in the post-industrial era. So we have what we have had to support and run our economies. What we have done, we have had a lot of industrialization. We have exposed our fossil fuel reserves. We have converted them from their earth sink to the atmosphere. So we have deposited the carbon which was stored for very long in the earth. We exposed them, we extracted them, and sent them into the atmosphere. And that's how we are facing different sort of impacts. Apart from that, we have had a lot of production of waste and pollution, which we have not been able to manage properly. And that has impacts across different sectors in the long run. Okay. And then we have been clearing different types of forests, converting them into farmlands. And that results not only into loss of forest, which has major role to play in storage of carbon, but at the same time, loss of biodiversity and changes in land surface characteristics as well. So what used to be a cooler place, perhaps that does not exist anymore, right? Because it has been converted into an exposed surface. And now the kind of interaction it is having with radiation is different, okay? And that leads to changes in the atmospheric and weather patterns as well. So what are the key components of climate research? Of course, we need to have observation. Why do we need observation? So that we can understand our Earth system better, right? Unless you understand how a particular parameter behaves, how it changes seasonally, how it changes from one place to the other, how it behaves within a day as well. So those sort of informations we should have so that we can translate this understanding into a climate model. Now, what do we measure on Earth? We measure weather parameters, something like temperature, and also a couple more, which I have discussed in the previous slide. We also keep an account of the sea levels, right? So that we are aware of what sort of changes are happening. We are also measuring CO2 concentrations. So you may have heard of Mauna Loa Observatory back in USA, which has been maintaining a record of CO2 concentration in the atmosphere for very long, right? And while we observe the collected data from the observation systems, what we do, we tend to translate that knowledge, how the wind flows, how the temperature changes, how much CO2 concentration we have, and how the plants interact with the Earth surface, and how the soil moisture changes in the Earth, etc. We tend to translate this knowledge into mathematical equations, which are called climate models, which are the basis of climate models. And then we kind of solve it for a longer period of time, right? Apart from that, what we use climate models is for attribution studies, okay? And what I mean by attribution studies is, suppose you had a particular weather event, right? Weather extreme event, and you want to see that, okay, we tend to understand our Earth system up to a certain extent. Now we want to know that whether this kind of intense weather event, which we have got, whether it is an artifact of the climate change, whether it has been caused by the climate change, right? How will you do that? You will have to kind of ponder upon this. And what we do is we tend to run climate models in different kinds of worlds, different counterfactual worlds, right? What I mean by counterfactual worlds is, so I will have one climate model simulation where I will simulate the event in the real world, how it looks today, right? Whether it compares with the observed signature or not. So that is your today's world. Now, if you tell your model that, okay, how this event would have looked like if we had smaller concentration of greenhouse gases in the past, okay? So you have the recorded greenhouse gases concentration. So you change this into the model, like you put 1960s, for example, I'm giving an instance, you put 1960s greenhouse gas concentration to your model, and along with other weather parameters, and you tell them that, okay, now simulate this event. And you do similar thing for a future world as well, where you say that, okay, this has been the pattern of greenhouse gases concentration, this has been the patterns of weather parameters. Now, can we project it into the future? Because we know already the trend, right? So you construct a future world as well, and you tend to simulate it in the future as well. And by finding the signals and comparing the signals, you'll be able to say that, okay, this event would have been much weaker in terms of its intensity and structure if it was a cooler one, or it will become much more violent and severe if it happens to be a warmer, right? Why this is important? This is important in order to develop, one, early warning systems, and second, the scientific understanding, and also developing the policies for resilience and adaptation. Okay. Now we have the knowledge about climate change given the different lines of evidences, but it is really important to communicate the climate change. So this cartoon over here, it shows that what are the keywords which we keep hearing more often? Okay. And one of the ways to communicate climate science is to simplify it. Okay. Simplification is really important to bring everyone along because we need everyone on board to solve the climate crisis. So this is an example of climate stripes. Many of you would have seen this. This is very famous. What it shows is the blue color represents the years when we had colder than average temperature at a particular location. And the red color represents we had the year where the temperature was higher compared to the long-term average. Okay. And if you see closely, you see that in the recent years, which is on the right side of the figure, we have had a lot of warm patch, and that tells you a story. That signifies that we have had quite a lot of warmer years than usual, than we would have expected in the recent years. Okay, and this is one of an effective way of communicating this, and there can be many others as well. Okay, but then the way it works is like there will be people who will be in complete denial and fake news situation. They'll say that, okay, we don't believe in it. Nothing has happened. You may have heard some of these statements by the US president or any other leaders of the world, famous leaders of the world. They say that these are all lies, these are hoax, but perhaps not true, right? The line of evidence suggests that we have been into a disguise, right? And the disguise is because of the presence of these giant companies, which has changed the fate. So bigger oil and gas companies, right? And perhaps they don't take the accountability, they don't take the responsibility. And then they go on spreading lies. Then they say that man-made global warming is the greatest hoax ever perpetrated on the American people. Perhaps that is not true. The truth is, right now, we are facing a man-made disaster of a global scale, which is called climate change. And perhaps it is so huge that we don't have mechanisms to reverse it back, right? So what can we do? We can try to slow it down. That is one. And the second thing is we can adapt to it. Whatever changes are there, we can adapt to it. And we will adapt once we understand it better, once we can have a better understanding of it. Okay. How the futures may unfold, that's what global climate models or different generations of climate models tell you. You may have heard of the Paris Agreement back in 2016. What they did was the world leaders, they sat together and they decided that, okay, climate change is happening and perhaps we need to act. How would you act? You will have to cut down on your emissions. But what that means you'll have to make some sort of compromises with your economic growth as well. Now, there are multiple facets to it. One of it is like not every country is in the situation or in a condition to slow down their economy, right? Because they have to feed the masses. So in that case, what they do is like they have nationally determined target, which they pledge, right? And it has to be in a way that we say we will try to limit the warming by slowing it down, and we'll try to keep it within 2 degrees Celsius limit, right? And then for that, for determining this, you tend to use climate models and this then say that, okay, if this particular country reduces emission by this particular year, what impact it will have, how they should implement the policies and action, and how they should update their targets and things like that, right? And how our future will look like will totally depend on our action, like how we act, how we behave, and how we respond. Okay, so this was from the physical science part, but then there is this risk framework as well, where we tend to understand the impacts of climate change. And the way risk is defined, you have this hazard, which is part of the physical hazard, something like extreme weather and climate events. And then there is this exposure, which tells that what is going to be impacted. It can be human population, it can be infrastructure, it can be economy, and many others. And then there is this vulnerability component, which says that, okay, how it is going to impact. So you tend to establish a relationship between hazard and exposure, right? And then say that, okay, if certain intensity hazard occurs, it will it will kind of have certain magnitude of impact on the exposure. Okay, so this was the old framework as part of IPCC report, in Intergovernmental Panel on Climate Change, and this is the updated framework where they have said that, okay, we have already had hazard, exposure, and vulnerabilities, but then it also depends upon the kind of responses we have. Okay, so this feedbacks into the total cycle. These kind of pictures these days have become very common, and we seriously have to think deeper that we have a planet, only one, which is in pain, and that sometimes it is really disheartening to see the condition of our society, condition of our land, right? And these type of figures are not for fear mongering, but this is for our realization that if there is a time to act and stop, that is now. We don't have to wait for tomorrow. Okay. So little bit about how the information which comes from the science is translated into policy. So you know that the different types of climate models, the kind of leverage it gives, the kind of experiments you can do with it, that informs international agreements and mitigation targets. Okay, and that also gives you an idea of how different countries or different regions are going to be disproportionately affected by the impacts of climate change and where the urgent action is required. Okay, and the overall scientific consensus guides actions like emission reductions and adaptation, like what could be the adaptation measures, how different communities can be targeted, how different regions can be focused on, and other related things. And then evidence-based policy, it again ensures global coordination, but then everyone has to come to the same page. Okay, so this is one example over here, which kind of gives that what kind of outputs do you have from climate models. So it shows that if we continue the way we act, the temperature of the earth is going to rise continuously, something like in the red line. Okay, but if we happen to ignore our model, and if we also happen to incorporate some of the mitigation and adaptation studies, perhaps, especially from the mitigation part, perhaps we have some scope left, but still it cannot be stabilized anytime soon, because if you see the x-axis over here, it goes up to 6,000 years, right? So we are here, the black dot, which is 2015 or 2025, which will be nearby itself. So there has to be very immediate action in order to kind of get the kind of response we want to reduce the impacts of climate change. Okay. This cartoon over here, it shows the life cycle of science to policy. So for example, you may have heard of IPCC, Intergovernmental Panel on Climate Change, which is responsible for collecting and summarizing all the scientific studies, and then it puts forth the summary for policymakers, right, and also other things, and that sets the agenda. Then the policy problems are structured, right, and then different global leaders, they kind of deliberate, and then if the cooperation works, then the different policy options are formulated, and then decision making takes place, and then those decision makings are kind of affected by political decisions. Then political decision leads to policy implementation, right? Like how much money will be required, how much infrastructure will be required, how the mobilization of instruments and institution has to happen. So one of the examples, National Action Plan on Climate Change. Okay, then periodic monitoring and evaluation happens, and then the learning experience and new knowledge is fed back into the cycle again, right? And this is how it keeps going. Okay, I will give you an example of India. So this is one of the recent question which was asked in Rajya Sabha, the upper house. So one of the members, they asked whether the outbreak of floods or cloudburst is increasing in several parts of India due to climate change. Now, you see how much urgent it is to address these things, right? And once we have the scientific knowledge which comes out from the climate data, climate science, these will inform the policy decisions at a higher level, and perhaps then that will mobilize different kind of funds and instruments and mechanisms which will lead to relief and early warning system in the affected areas. Okay. And this is another question which was put forth recently this year itself, August, and it was about rising incidents of extreme heat. Okay, and once the scientific knowledge, the credible knowledge is passed on in a simplified manner with a level of credibility, perhaps then the action will happen. So there is definitely a lot of opportunity where we have to come together. We have to produce robust science, which again informs the policy, and that will result into action, not only for the mitigation, but also for the adaptation and relief. Okay. I will give you some classic examples of climate science influencing decisions. So Paris Agreement, which happened in 2015-16, it was informed by IPCC assessments. So IPCC, they collated together all the reports, all the scientific studies, all the lines coming from different lines of evidences, and then it gave the summary of the status of the knowledge we have. And based on that, the world leaders gathered, and then Paris Agreement happened where many of the countries were signatory. Okay. So IPCC reports, it provide synthesized scientific findings for policymakers. It does not do any modeling or any science on its own, but it is a body which summarizes the findings for policymakers. And based on these sort of reports, there are national adaptation plans, which are again based on regional projections and risk assessments. Okay. I will give you another instance where the scientific basis is translated into a policy. So you know that different kinds of climate shocks, extreme weather and climate events, it results into the risk to our financial systems. Okay, something like banks. So there can be stranded assets or non-performing assets which are impacted, and the financial risk is so huge that it cannot be recovered, and it becomes a burden on our financial system, right? So RBI in our country, Reserve Bank of India, it has taken initiative to set up a repository of information on climate risks, which are relevant for the financial system. Okay. Right. Another tools which are important for decision support. So not only physical climate models, the output from physical climate models, they are used and they are trickled through the integrated assessment model, something like an energy model, something like an emission modeling model, right? Something like an impact model, something like a financial model. Okay, and then the risks are calculated. This also informs the climate impacts and vulnerability assessments. Then again, it serves a basis of understanding and pricing the carbon budgets, and also to track emissions across different sectors. So you may have heard of something like a task force on climate related financial disclosure. So this framework kind of uses these kind of tools. Again, it facilitates international collaboration just by delivering the cutting edge science. So IPCC, World Meteorological Organization, UNEP, UNFCCC, these are the organizations which rely heavily on the scientific knowledge produced by these climate models, climate science, and then they lead to global climate action on a coordinated basis. Okay. But then there are a couple of challenges in linking science and policy. It is not very straightforward, right? And one of the major one is political and economic constraints. And we have a classic example of the USA acting or putting forth their stand on climate change related issues, right? And these are something which gives you an example of how one particular action can drive the direction of coordinated efforts, right? Because the onus comes to the other parties then, okay? And what happens is these are the giants who have all the instruments, all the perhaps resources, if not all, perhaps better resources compared to the ones who are facing the impacts of climate change, okay? The another thing is uncertainty communication. Uncertainty means there can be a range of possibilities which we are not sure about, because we cannot actually go into the future and identify what is going to happen. So what we do is we tend to get to a best estimate so far based on our understanding. So uncertainty in the future projections or future climate has to be communicated clearly and carefully. Okay. And again, this keeps changing as the science progresses, right? And then there has to be some sort of consideration on equity and responsibility as well. So the disproportionate impact of climate change is so large that many of the countries who would not have emitted a lot of greenhouse gases, but they are still at the verge of facing severe impact. So that tells you the kind of inequality we have in the global geopolitical scenario. And that kind of acts as a major challenge in linking science and policy. So what can be the future directions? We can have improved climate projections, and of course this is a science problem, but at the same time it also depends upon the kind of faith the society and government has in the scientific developments, right? And they have to keep supporting, because the field of climate modeling is again very new. We did not have very sophisticated computer back 20 years. Now we have it. We are taking leaps, and especially with the advent of machine learning and AI, there are so many things which are going to happen, and perhaps we don't know how the future of climate science may unfold in the later time. Okay, at the same time, we cannot keep waiting for our climate projections or climate models to become perfect. We also have to integrate in our knowledge system the indigenous and local knowledge which comes from years of experience of human civilization, while a stronger global cooperation for adaptation and mitigation is also solicited. Okay. Now, since we are talking about all this, you may think that, okay, this looks like a very high level thing. What can I do? Where can I do my bit so that I don't feel bad about it? I should also contribute responsibly. And there are a couple of avenues where you can do that, right? You can do personal lifestyle changes. And you would think that, okay, if I switch off a light when I'm not attending a room, perhaps that won't make a difference. But see, we are huge in numbers on this earth. If we happen to do so, we'll save some energy. We will kind of contribute to burning of lesser fossil fuels. Okay, if we can take a train or a public transportation system instead of flying or a personal vehicle, perhaps that will count. Okay, we should reduce, reuse, recycle, do sustainable practices at our home, and every single effort counts. Okay, make your voices heard. How you can do that? Make yourself aware. Uh, get the information on what are your rights: right to clean air, right to a better climate, right to a livable environment, and also vote sincerely. Also make your voices heard. Convey your convey your anxiety or convey your stresses about climate, weather, environment to your local lawmakers. Perhaps that's the way to go about it, because they will translate it into policy, and perhaps that's how it can be heard. Of course, there is a long way to go, but that is something which can be a starting point. Use your leverage, right? Keep upskilling, try to understand new things, and try to generate new knowledge if you can. That is also very important. Okay. One of the avenues I wanted to tell you, since we are talking about it, I mean, if you wanted to take it formally, and if you are interested in it, there are a couple of ways in which you can join the hands, in which we can create the workforce. So at Azim Premji University, we have a couple of master's program where you will not be only working on the science part, but also on the climate action, also translating the knowledge and understanding to the society at the grassroots level. So we have this master's program in education, public health, right? Of course, climate change is very important there. Also MA in education, then MA in economics. Then we have a very specialized program which prepares the next generation of future climate leaders. And that program is called MSc in Climate Change and Sustainability, which started this year. So we are currently having a fantastic set of people who are coming from across different disciplines. So not necessarily everybody is coming from the science. They are coming from management, they are coming from engineering, they are coming from economics, geography, science, and much more, public policy, etc. And they are bringing different flavors to it so that we can have a discourse which accommodates every aspect of climate change. Okay. At the same time, we also have a 4-year environmental science and sustainability program. And this cartoon, this slide over here, it shows the structure of it, and this well aligns with the national education policy. And one can opt for either 3-year degree or a 4-year honors program as part of their study. Okay. This also provides an opportunity of carrying out the research and internship. So, I mean, if you are interested in doing some research, if you are interested in doing some action-based work, you can go for internship as well. Okay, these are some glimpses of the program. So something like this cartoon over here shows that, okay, what is the mystery of Belandur Lake in Bengaluru? Like why it had changed, how it had changed, who will take care of it, who will act, who will respond, and things like that. These kids are there out in field. They are trying to understand things while connecting to the real world. A little more about MSc Climate Change and Sustainability Program. So we have two options. 1 year is coursework. The first one is 1 year coursework, and the second one is 1 year of coursework and 1 year of research. And these are the courses we are offering to the people. Something like climate change and planetary boundaries. You would be surprised that 7th out of the 9 planetary boundaries have already been reached. So perhaps if there is a time to act, it's now. How renewable energy transition might happen, research methods, life cycle assessments, sustainable water and solid waste management, sustainability reporting, geospatial analysis, programming, climate investment and risks. And this not only includes the climate science, the theoretical climate science, where you will apply the physical, chemical, mathematical understandings, but this also relates to the action, how it gets translated to the real world. These are some example career options. So you can be an ESG analyst, climate policy analyst, you can go for research, you can become a renewable energy specialist, you can work with NGOs for grassroots work. And then the kind of teams we are open to, people can come from science, policy, humanities, engineering, etc. And I mean, what we believe is, like, if you happen to join us, you will definitely make a difference and you'll become a catalyst for the anticipated change, which we all are looking forward to. Okay. If you have any questions for program related information, please reach out to this email ID. And with that, I would like to stop at this point, and I'm very happy to answer the questions you may have. Thank you. I can see some of the questions in the chat. So someone wants to know about the atmosphere. So atmosphere is an envelope of air which surrounds the Earth, right? And this is composed of different gases, okay? And these gases are essential for the functioning of Earth. If you want to know more, I mean, there are much more technical details. I wanted to tell you in a simplified manner. Can you explain what are the parameters you are using for climate modeling? Yeah, so climate models are based on different sort of, first, I mean, climate models use equations which we have derived based on the observations, right? The way we understand the physical processes, something like changes in wind speed, how the wind circulation takes place, how the evaporation happens, how the cloud forms, and how the rainfall happens, right? Those sort of things, how the radiation comes to the earth, those sort of things, okay? And we use these observations to start or initialize our climate model. So some of the parameters which are used are the wind speed, right? Because wind speed is essential for carrying a lot of mass, something like water vapor, and energy. So air parcels, they have some temperature, and the total energy received in the tropical region, those are transported to the polar region by the air masses when they get warm, and then they rise, and then they find their way towards the pole. So these sort of things we are trying to represent in our models. Yeah, so I was talking about the parameters. So it's temperature, pressure, wind speed, humidity, etc. Apart from that, we also put in our climate models the land use parameter. Where is your ocean? Where is your sea? Land sea mass. Sometimes we also put that, again depends upon the use case, but yeah, we also put greenhouse gases information for simulating the climate change. How to prepare for entrance test for climate change and sustainability? Yeah, that's a very good question. So what we are looking for is, like, we are looking for individuals who are interested in pursuing this career, and they should have at least some background in quantitative analysis. So they should be comfortable with quantitative understanding. If they have some programming experience, if they have done some analysis in geospatial science, I mean, those kind of people will be much more suitable. But at the same time, people should also have some basic understanding of climate change, climate science, how the impact happens at different levels, and how can we kind of translate the understanding of climate science to real world, those sort of things. If you have some basic idea, perhaps that will do. But I assume that even if you are coming from geography, if you are coming from engineering, if you are coming from policy, perhaps you are bringing a different flavor. So to summarize, perhaps you should focus on the quantitative methods and simple simple basics of climate change and environmental sciences. How are climate change and sustainability related to civil engineering? That's an interesting question. So, for example, in civil engineering, you learn a lot about water resources. You learn a lot about droughts, floods, etc. Right. So you see that the climate change tends to impact these sectors at different scales. So perhaps that answers your question. Talking about sustainability, you see that, I mean, the sustainability is a major challenge of our current times. I mean, you also learn about solid waste management, designing landfills, how to maintain how to manage the waste, and then how to design sustainable drainage systems across cities, how to design perhaps the energy systems, etc. So these are the things, while being an engineer, you can think of. These are the points you can keep in mind. Are there any more questions? Please feel free to drop them into the chat. I'm happy to answer. What are the jobs in climate change and sustainability? That's an interesting question. So you can join different consulting firms like ESG analyst or sustainability manager or climate policy analyst and things like that. Those are some of the examples. But at the same time, you will learn skills which will be transferable and which will be very useful to apply in other sectors as well. Something like geospatial analysis. Okay. So then you can work with different NGOs. If you want to pursue higher research, you can do that. If you want to go into academia, you can do that. So these are some of the example jobs. You can work for banks as well because they want to understand that how much financial losses or how much financial burden or liabilities will occur given the impacts of climate change. You can work with different other kind of firms, something like the firms which work with agriculture sector, the firm with which work with water managers, the the firm which is working in the construction sector, etc. So there are plethora of opportunities if you understand this subject, if you have relevant skills, and if you are kind of willing to put in hard work. Perhaps that's the way to go.
Thank you so much, Dhirendra, for such an informative and interesting session. Thank you so much for responding to all of the queries that we got in the chat. I really look forward to the series of conversations that we'll be having with faculty from the School of Climate Change and Sustainability. Dhirendra, any last words for our audience?
Yeah, so first of all, I would like to thank everyone for being patient. And I mean, I would like to tell that, I mean, it's never late if you want to act to stop or mitigate the climate change. It's time now. And perhaps every action counts. Like we have to start sustainability with ourselves, right? We don't have to wait for the government or some other agency to bring in regulations. We don't have to do that. We can do small things, and those small things will make a huge difference. I am happy to chat more about it. If anyone has any further questions or any sort of queries, please drop me a word. You'll find me on the university website. My email ID is there. Please drop me a word, and I'm happy to connect and take it from there. Many thanks again.
Thank you. Bye-bye, everyone. Good evening.